Okay, so we're going to look at building a deck today. So exciting. Builders use various methods for laying planks on a deck. There are aesthetic and practical considerations to take into account when deciding on the deck pattern. Diagonal, horizontal, herringbone, vertical. Today we're going to compare horizontal and vertical planking methods for decking a region. Imagine you're building a deck on the region shown below, enclosed by the curves y equals 2x plus 4, that would be the line, and x minus 5 equals negative y, negative, the quantity y minus 4, quantity squared. Okay, so that's a parabola opening sideways with a vertex of 5, 4. So okay. So on the first graph, sketch what it would look like to use horizontal planks. Pretend I did a better job making those even. Right, something like that. On the second graph, sketch what it would look like. Vertical planks, sorry. Sketch what it would like to be horizontal. Okay, pretty straightforward. When using vertical planks, at what x value do the planks start at? So if I'm going to use the vertical planks, x equals negative 1.25 all the way to x equals 0.5. Excuse me, not 5.5, just 5. So negative 1.25 to 5. But it's a little strange, right? Top and bottom, right? It's a little bit funky as we go along. Okay. When using horizontal planks, at what y value do the planks start and what y value do the planks end? Well, if I go horizontally, they start at y equals 1.5 and end where y equals 6. If they're going to use 20 planks or 20 boards, how wide would each plank be if the boards are laid vertically? So it's going to be delta x divided by 20. And so the change in x is 5 minus negative 1.25 over 20, which is equal to 0.3125. So that's my vertical. And again, that was delta x divided by 20. This will be delta y divided by 20. And so it will be 6 minus 1.5 over 20, which is 0.225 for horizontal. Which method of laying the planks would make it easier to determine the length of each plank? So would it be easier to determine them this way or this way? So up until I get to 1, I can go top minus bottom, no problem. 2 different curves. But from 1 to 5 on this, I'm going on the same curve, which is weird, which means I would have to define it in terms of x 2 different ways. Okay. So in that sense, I need more definitions. This one would just be this right curve minus the left curve. Curve on the right minus the curve on the left. So I think it's horizontal by a lot. Planks because the length of each plank length I can spell. You've been good at it sometimes. Of each plank is the difference between y values, between x values, excuse me. when we use vertical planks, the upper and lower planks change, upper and lower curves change. Okay. Write an expression that would give the length of a horizontal plank at a given y value. Okay. So if I took my equations, x would equal negative y minus 4 quantity squared plus 5. That's the right curve. And my left curve, which is this function here, I'll do this in green. I'll go ahead and solve it up here for x. Y minus 4 equals 2x. So x equals 1/2 y minus 2. Okay. Okay. So that's my left curve. So the length of a plank will be negative y minus 4 quantity squared. And then instead of adding 5, I'm going to put the 5 in front. That just makes more sense to me. Minus 1/2 y minus 2. Just that. That's my length of the plank. All right. So what is the exact area of the deck? The integral from 1.5 to 6. Notice these are both y values. So y to y on the picture, y to y. And so then my length of my plank will go inside. So we have the length of the plank. And width of plank. I start with WD, I don't know. Now, this is one of the greatest things about your calculator is it doesn't care what variable you use. It doesn't know if it's x or y or t or q or w. So I am going to just type these, and instead of y, I'm going to type x, and it won't know. I'll have no idea. I'll figure it out. Math 9 from 1.5 to 6. First equation, parentheses, so 5 minus parentheses, x minus 4 instead of y, quantity squared, minus next parenthesis, 1 over 2, I'm going to go with 0.5, yx minus 2, close that parenthesis, dx. I can just switch y for dx. Oh, there it is. And so that was fast. Must have been an easy one. Because I could have easily integrated that by hand. It wouldn't have been bad. Equals 15.1875. And there you've got it. No big deal. So once we feel comfortable with area, we can switch back and forth between area in terms of x and area in terms of y. So back we go to, not quite, I didn't pull it down quite enough, our important ideas for topics 8.6 and 8.5 and 8.6. So 8.5 is functions of y, 8.4 is functions of x, and 8.6 is choosing and applications. So let R be the origin. I'm not doing that. So if the upper curve requires 2 or more definitions, so like we had to switch what upper meant because we had this was upper for a while and then something else takes over, then it's easier to say left and right. And make horizontal rectangles. When we do the area of region R, I should have written an R right here. We do the area of region R. We go from C to D, which in this case are y values, with f of y and g of y dy. So these are functions of y, and then if I go like this, hey, I have functions, no problem. And it's just the same. It's just, it gets a little bit switched and confused. And there you have it. We'll talk again soon.